Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshops and exercises to learn about AWS services. These workshops and exercises are published to our website aws-dojo.com. Today, we are going to talk about how you can perform machine learning with data in Amazon Redshift. It is also called a feature Amazon Redshift ML, and this feature was released by AWS during the reInvent time. It is still under preview, but let's see how it works. So basically, if you have some data in Redshift and you want to use that data to create some machine learning model, then this feature is useful to you. Since this feature is still under preview, let's try to understand that before this feature came, which is still under preview by the way, how people used to perform machine learning with Redshift based data. So assume that you have some data in Amazon Redshift and you want to build a machine learning model based on that data, and you want to reuse that model inside Redshift. So what people do, there are certain steps involved. So along with Amazon Redshift, two other services which were used were Amazon S3 and Amazon SageMaker. So the steps involved was that you will export your training data to Amazon S3. Then you will use Amazon SageMaker to actually train the model using this data, this training data, which has been exported to Amazon S3. Then once your model has been trained and deployed, then you export your test data to the S3 bucket so that you can make some prediction on your test data. Then what you will do that you will use this test data and the trained and deployed machine learning model to make the prediction about your test data, and then that prediction is saved back to the S3 bucket. Then that prediction is imported back to the Amazon Redshift, and then finally you can query the prediction about the test data. So these were the typical 6 steps involved in order to use machine learning within Redshift. And you can see that majority of task was happening in Amazon Redshift, majority of task is happening inside Amazon SageMaker, and actually Amazon Redshift is primarily responsible for exporting the data, then when the prediction has been made, importing the data back, and then use that prediction data in your queries. It all works very well, but it was so many steps involved, which actually increases the whole machine learning, the whole training time, deployment time, and then also consumption time. With Amazon Redshift ML feature, this whole workflow will be very much simplified, and you can achieve the same result without hopping into multiple services like you see here, S3, SageMaker, Redshift. In fact, sitting inside Amazon Redshift, you can do everything, and that everything means you can train your model, you can deploy your model, and then finally you can consume your model sitting right inside Amazon Redshift. So let's see if you use Amazon Redshift ML feature, then how this whole workflow look like. In this case, again, the services you will use will be Amazon Redshift, S3, and your Amazon SageMaker AutoML. But literally, you don't do anything in S3 or like you create some bucket in S3, of course, but you don't do anything into Amazon SageMaker AutoML. You do all your activities, all your tasks inside Amazon Redshift and get your job done. So let's if you start understanding the whole flow, you have to keep your train and test data inside Redshift. You don't need to do any export or import like you were doing in the earlier approach. Then you can create the model sitting right inside Amazon Redshift. So when you're training your model, you don't need to go anywhere. Sitting right inside Amazon Redshift using SQL kind of statements, you can start training your model, start creating your model. And at this point of time, actually what happens is that when you create a model inside Amazon Redshift, the model creation is, or model training is handed over to Amazon SageMaker AutoML, but you don't need to do it. Actually, Redshift does it for you. So all you need to do is that, okay, here is my training data. Here I start training my model, and that's it. And then Redshift takes responsibility of handling it over to AutoML so that AutoML can do the training of the model based on the most suitable algorithm. Okay, and once the model has been trained, it is deployed back to Redshift as a SQL function. So again, you don't need to do anything from the deployment point of view. So when you train the model, you say I'm training the model. At that point of time, the model will be trained by Amazon SageMaker AutoML, and then it will be deployed back to Amazon Redshift as a SQL function. And then all you need to do is simply you use this SQL function to make prediction inside Amazon Redshift. So as you can see here that it does not involve multiple steps of exporting, then modeling, then deploying, and then make prediction, and then import back. All those things are gone. You're sitting right inside Amazon Redshift, and then you are simply performing training of your model, which is doing the deployment as well. And then simply it is once it is deployed, you're simply making a call like a SQL function in a SQL function and making the prediction. So much more simplified than what it used to be earlier. And what we are going to do, that we are going to do this, I'm going to do demo of this whole thing, and then you will realize how simple it is. But let's try to understand some of the fundamentals first. Now, with Amazon Redshift ML, there are two types of algorithm it supports, and that covers most of the typical algorithms you talk about. So it supports classification algorithm where you can solve problems like, okay, based on my data, tell me if the customer will churn or not, or based on the data, tell me if this sales lead, this is a winnable sales lead, or it is not a winnable sales lead. Looking at the data, can you tell me what kind of risk, insurance risk you predict, whether it's a low risk, medium risk, high risk? Or looking at the data, can you tell me whether it's a fraud case or non-fraud case? So if this kind of classification problems you have, you can solve it using Redshift ML. The other types of algorithm which it supports is also called regression algorithms. And an example of the regression algorithms are, can you tell me my sales or revenue prediction for a certain time period or a date? Can you tell me what the price of the product will be in the future for a certain time period or a date? Can you tell me based on the customer data that what is the lifetime value this customer is going to provide me? Yeah, prediction like that. So you can do both a classification and a regression type of algorithms with Redshift ML. Okay. So moving on, so how do we configure Redshift ML? And again, it's pretty straightforward, very simple. I'm going to show you. I'm going to do it for you. In fact, what you will do is the first step is that you launch an IAM role for Redshift, and this IAM role should trust both Redshift and SageMaker, and it should have S3 and SageMaker full access. So you need to create an IAM role like this. Once you have created the IAM role, then you launch Redshift Cluster with this IAM role associated. Then you upload your train and test data to Redshift database. So in Redshift database, you simply upload your training and testing data. Then you simply create model. Right inside Redshift, you create your model. That means you're training your model based on your trained data. And once you create the model, actually it completes the whole life cycle. That means it will train your model and it also deploy your model as a SQL function inside Redshift ML. And then finally, you use the model. That means you use that SQL function to use the model. So these are the typical 5 steps involved in order to configure Redshift ML in Amazon Redshift. And again, I'm going to do this for you so you will get a complete experience of how it works. So moving on. So how does your training and test data look like? I think let's spend some time understanding that as well, because that will help you understand how to make use of your data actually. So, and it needs a little knowledge of you knowing how machine learning works actually. If not, probably you might want to read some articles and that will be enough. But let me explain what I can explain even for those guys who has probably not know much about how machine learning works. So basically, when you are working with when you're doing you're training your model and you're working with machine learning, actually, your data will have 2 parts. One is called your target column or target data, and that is the data for which you want to make prediction. So like I told you example, tell me that customer is a fraud or not. Tell me the risk of the customer. Tell me the lifetime value of the customer. Tell me the sales, production sales, prediction of the product sales on a certain date or certain date range. That is your target column. And then you have feature columns, and feature columns or feature data are used to train the data. So of course your target data value depends on your feature data value. And the whole idea of the machine learning is to build a model which can look into your feature data and can make some prediction about your target data. So your data should have both feature columns and your target columns. So target columns is what you're making prediction about, and your feature column is what data you're using to train the model so that you can make prediction. Yeah. Now, how many ways you can store this training and test data? And one approach is that you can use one table. That means in one table, you're keeping both your training data and your test data. And difference between training and test data is that training data is the data which you use to train the model. Yeah. So when you create your model, when you train the model, you use certain data. That data is what you want to use for the training of the model. And once the model has been trained and deployed, then you make prediction for certain on certain data, and that prediction you can make for testing purposes. That prediction you can make for actual use case purposes, and that kind of data is called your test data, the data which you have not used for training but you are using to make prediction using the model. Okay, that is called your testing data. Now, in one scenario, your training data and your test data both could be in one table. Yeah, that is very much possible. And in that case, when you're trying to, and then in that case, you use SQL query to fetch the training data and the test data. So you will use SQL query to say, and generally like when you say SQL query, like you use a timestamp kind of method. Okay, so you can say that, okay, 2020 and earlier data I'm going to use for training purposes, and 2020 onwards data I'm going to use for test purposes, and you can then use SQL query in your single table to fetch your training data and test data as you need it. Okay, so one approach is that you can keep your training and test data both together in one table. That is possible. In that case, your table will have your feature column and test column both together in one table. But other approach is that you can have two tables, one for the training data, other for the test data. So your training data will have your training data table, which will have your a feature column and target column both, but your test data will have only feature column. And why test data has only feature column? Because you want to make prediction about the target using the feature values. So it has only feature columns. It does not have any target column. Okay, so keep this in mind, guys, that you can have your data organized in two ways. You can have both your training and test data in one table itself, or you can have your training and test data in two different tables as well. When you keep into one table, then you use SQL query to segregate your training data from the test data. Okay, so having understood that, how do I create the model? Because to be honest, you have your training data, you have your test data, you're creating your IAM role, launching Redshift cluster, all is good, but the real meat or the real thing starts when you create the model. So let's try to understand how do you create the model. So in order to create the model, you run a SQL statement in Redshift. And the first statement is called create model, and then you give a model name. Very simple. Create model, give a model name. Then you say, where is your training data coming from? And then here you can either provide your, if you are keeping your training data and test data in separate tables, then you can simply provide your training data table name here. Yeah, if you're keeping your training and test data in separate tables. But if you're keeping your training and test data in one table, then you can use a SQL query to tell, okay, this SQL query will fetch me the training data from that single table, which is keeping my training and test data both. Yeah, so my SQL query can have my training and test data both in one table. My training and test data can be in one table itself. In that case, I can use a SQL query to fetch my training data. So you fetch your feature and target columns both using this SQL training. So your second statement provides data for the training data for the model. Then you mention target. So what field you are going to use for prediction? Like I told you, that sale of the product, customer churn, risk with the insurance, customer value for the lifetime. Okay, so which field is holding my target data? Then, so that field name. Then when you build the model, when you train the model actually is deployed as a SQL function. So in Redshift. So what is the name of that function going to be? And I see some typo here, guys. I'm sorry for that. So what is the name of the function going to be here? So you provide a name of the function here. Then what IAM role we are going to use. So remember, we created one IAM role which associates with the Redshift cluster. So you provide the ARN of the IAM role. And then Redshift also uses an S3 bucket internally. You don't need to worry about it. You just need to create a bucket for all these training purposes and those kind of things. So you need to also provide a bucket name here, the bucket which Redshift cluster will use behind the scene with SageMaker for all these training and prediction purposes. So you have to provide the bucket name. So this is the SQL query. This is the query you have to run inside a Redshift cluster in order to start training your model. And again, I'm saying start training the model because when you run this query, it takes some time to finish training your model. And you can use this show model all and this show model and model name query to see the state of your model, whether it's still training or the training has been finished and so on. So this is how you train the model. And once you have trained the model, then you use the model. And in order to use the model, you make statement like this. So for instance, you will say select and I told you that when the model is trained, it is deployed as a SQL function. So you have to call that SQL function in your select query in order to make the prediction. So you simply say select and then the function name, and to this function you have to provide parameters, and your parameters are your feature column, because based on the feature column you tell what is going to be my target value prediction. Okay, so you simply say select function name, then you pass the feature columns here, and then you say, okay, this value I'm going to use as some predicted value, some field name, for instance, customer churn, or product sales forecast, or insurance risk forecast, and those kind of things. And then you have to mention from where the data is coming. And again, in this case, if you have created your separate tables for test and training data, then you have to provide your test data table name over here. But if you have the same table for both training and test data, then you simply provide this SQL query statement, which will fetch only the test data from the table. And you run this query, and what it will do, that based on this feature value and using the deployed model, using this SQL function, is going to make a prediction about your data, and then it will present back to you. And again, I'm going to do this for you, so you will realize what exactly I'm talking about later. So what are we going to build today? So having talked all these things, what I'm going to build today, I got some sample data, free downloadable from internet, and I'm going to use here. And this data is actually a very interesting data. It says that it has, for instance, this is data about the wine quality. And it says that based on the chemical composition of the wine, it can make a prediction about the wine quality, and it makes prediction based on from 1 to 9. So it will give you a kind of number to the quality, whether it's a 1, 2, 3, 4, up to 9. And basically what you see here in this data is that it has got your acidity data, sugar data, chloride, sulfur dioxide, density, pH value, alcohol. These are the chemical composition it analyzes in the model, and based on that it makes a prediction about the quality. So the quality is the target data, target column, and this alcohol, sulfate, pH up to this fixed acidity you see here, these are the feature values. So based on this feature value, feature columns, it's going to make prediction about the quality. So this is what we are going to use as a sample to build a model, so which will simply use chemical composition of the wine to predict a quality about the wine. Now, for this purpose, we have divided our data into two tables to keep it very simple. So one table is called your wine quality train data, where we keep the training data, and you can see this in the training data you have got your feature columns as well as your target column. And then if you look at, and target column is quality, by the way, here again, just to reiterate. And then another table is your wine quality test data, and wine quality test data has got only feature columns, and here you use this data to use the feature column values to predict a prediction about the quality. You make a prediction about the quality. So this is what we are going to use today in our example for the demo. So let's see the demo. So going to the AWS console, let me show you first what configuration, some configuration I have already done in order to save the time. So you can see here that in this example, actually, I created a bucket called Dojo ML data. In that, I created two folders, test data and training data. And here I kept my training and test data so that I can import that data into the Redshift cluster. So just to show you data, let me show you the training data. So if I go to training data and simply select it and use, I want to say, let me make a SQL query here, just to see the preview of data. So I'll not do much. I'll simply show me top 5, run query. And you can see here that it has got this fix is a data over here, and this data is actually what. To be honest, I'm keeping this data inside Redshift into S3 bucket, but this data I just kept it here so that I can import into Redshift cluster. And to save time, I have already imported it into Redshift cluster. But just showing you that you might want to keep your data inside S3, and from there you use this copy command to import inside a Redshift cluster. So this is my so I have two set of data: training data and test data. Then I created another bucket called Dojo ML out, and this bucket I am going to use to remember that when you train the model, Redshift cluster needs a bucket which it can use for training the model, making the prediction, and those kind of things. So this is the bucket which I'm going to mention in my configuration, which Redshift can use for machine learning purposes. Then I created an IAM role, Dojo Redshift IAM role, which actually had got two permissions, Amazon S3 full access and Amazon SageMaker full access, and it trusts two services, Redshift and SageMaker. Okay, so this is also good. And then here is my Redshift cluster, which is a DC2 cluster actually. And if you look at this cluster, first configuration I want to show you is that this cluster is associated with Dojo Redshift ML role. So the role is associated with the cluster. And one more thing, since this feature is under preview, right now if you try to use this feature, you have to use a maintenance track. So I have launched this cluster using this SQL preview maintenance track, but this you need to do only till this feature is under preview. After that you don't need to mention. Once this maintenance track becomes your generally available, then you don't need to mention it. You simply can launch Redshift cluster like you launch in any other case, and then you can use this feature with the main track or general available version. But right now, if you're trying to use, you have to follow this maintenance track SQL preview. And then, so this is my Redshift cluster, which I have launched. And then in this Redshift cluster, I have created two tables. One is wine quality test data, and second is your wine quality training data. Wine quality training data has got data populated from your training data over here, and then wine quality test data has got data populated from your test data here. So in fact, this S3 bucket I don't need anymore because I have my data populated into my training and test data. So if I make a query to say, okay, let me see my training data first. So we can, once you run the query, you can see here is that in my training data actually has got, it has got 1559 rows, and if you look at the values, you can see here that it has got your feature values, and here is my target value quality, which has a value from 1 to 9. Yeah, 1 to 9. And if I try to change this and say, let me see how does my test data look like. So if I say test data and I run my query again, then I will see my test data, which will have only my feature value, not the target value. So you can see here that it's got the feature value, but there is no quality field here because we want to use the feature value for this set of data to make a prediction about the quality. So all those things are in place, and what I'm going to provide, I'm also going to provide you all these instructions, and I will provide also link to this data so that you guys can run this whole demo by your own if you want to make your hands dirty with this. So my data is ready, my cluster is ready, my roles are ready. I can now start creating my model. Okay, so for that I'm going to run my query. So here I run my query and I'm saying, okay, create model. I'm creating under public schema. This is a wine quality model. It's running on my wine quality train data. So I'm mentioning the table name where my training data is there. My target column is quality. And then once this model has been created, then it should be deployed back to Redshift using as a SQL function. And that function will have name predict wine quality. So in future, I'm going to use this as a SQL function to make query for the prediction. This is my IAM role ARN for Redshift, and this is my Dojo ML out bucket. So remember guys, I created a bucket Dojo ML out, which Redshift and SageMaker both will use for the machine learning purposes. I simply told my bucket name. So let's run this query. And the query should be successful. Hopefully, yeah. Okay, let's see, it's still running. So just wait for this query to finish. And finishing the query doesn't mean that your model has been trained, but it means that your model training has started. So you can see here, it says that it's completed. That means my model training has been started. Now I can see all the models, and for that I can run another query here. For instance, this one. This will show me all the models which has been trained. So you can see here, it shows that there is a model called wine quality model under the public. Okay, so this model is getting will be created. In fact, so it's already created. Only thing the model is created. Only thing it is the training of the model is not complete. Then I can say, okay, can you show me the details of this wine quality model? So if I run show model and then name of the model itself, then it's going to show me the status of the wine quality model. So it shows you status of the wine quality model. It is saying that, okay, well, this is the model name, schema is public, AWS user is the username. Right now the model status is training. Okay, it's not ready yet. It is under the training, and the data it is using is from wine quality training data, and the target column is quality. So to be honest guys, at this point of time, it is training the model, and we have to wait till training is complete, and it can really take some time, because now at this point of time your model training has been offloaded to SageMaker AutoML. SageMaker AutoML is automatically going to train your model based on the best suitable algorithm for this kind of data. And then once the model has been trained, it is going to deploy. It is going to deploy it back into SageMaker as a SQL function. And at that point of time, we can start making prediction using your test data. So what you have to do at once you are at this stage is that you can simply you simply wait for your training model to be ready, and you can run this SQL statement again and again to check the status of your model, and the ones it is not in training anymore, it is ready, and then at that point of time you can start making call to the SQL function and start making the prediction. So at this point of time, I'm going to pause my video and I will resume back again once my model has been trained. Okay, so it took more than 2 hours to finish training the model. So if I make query again and I check the outcome of the query, you will see that your model is ready. So if we look at the details now, it says okay, fine, the model is ready. Accuracy is close to 69-70%. This is the estimated cost of using the autopilot along with Redshift, and you can see that so the model is ready for the consumption. Now what has happened is that it has using your data, it has trained the model in SageMaker AutoML, and then the model has been deployed back to Redshift as a SQL function, and all you need to do is to simply call the SQL function and no prediction about the data. Now, one thing I want to, let's try to make prediction, and before I do that, let me so if I try to see my data again, my test data again, this is how my test data look like. So if I run my select query on test data, my test data has got my feature data, which is basically the chemical composition of the wine, and it has no quality column here because quality is the target data, and that's what we want to make prediction about. And my test data is in the table wine quality test data. So now what I'm going to do is that I'm going to use the SQL function we created or deployed for the model. I'm going to use that SQL function to make prediction about the data wine quality in this wine quality test data. So to do so, we will run a select query on the SQL function. Let me copy paste this query over here. So here I'm making the I'm doing the copy paste of the query. So basically, if you look at this this function over here, this is the function name we mentioned when we created the model, and this is the function which has been deployed, and this function actually, you can say, represents the model which is deployed for the machine learning. And then in this function, we are passing these feature data. And this feature data we are passing as parameters. So you can see that acidity data, acidity, sugar, chloride, sulfur, dioxide, density, pH, all these values we are passing as parameters to it. And then this we are saying is and whatever the outcome of this function is, that we are giving a column name or alias saying predicted quality. And then of course this we are reading from wine quality test data. So all it's saying that select the feature columns star, then call this SQL function which represents the model, passing the feature column data as the parameters to it, and whatever outcome, an outcome will be basically a predicted quality or prediction about the quality using the model, that we are saying a predicted model, and that's it. So now if I data, and if I run this query here, so if I run this query, hopefully it should work, and it is going to give me a prediction about my data in wine quality data in my test table. So let's wait. Yeah, so it has got 40 rows, and then these are the feature data, and in the last, now it has added one predicted quality column here, and this is the outcome. This last one is the outcome of the SQL function, which is representing the model here, and it is basically giving the prediction of the wine quality ranging from 1 to 9. So basically, the way you can interpret it is that if this is my chemical composition, then my wine quality prediction is 5, and 6 if this is the chemical composition. So that's how the data modeling works, or machine learning works in the Redshift. As you can see that I really don't need to leave my Redshift environment, and I can do the whole machine learning, whether in terms of managing your data, to training your model, to consuming your model, right inside the Redshift cluster. So that was all for today, guys. I'm going to provide a script to run this whole demo and also the sample data and everything in my description section, so you can download it from there. Yeah, and I hope you like this video. And if you like this video, please click on the like button. Please subscribe to my channel. We always look forward to your feedback for improvement, for changes, for correcting our mistakes. So if you have any feedback or comment, please provide us in our YouTube channel comments section. So we always look forward to your feedback. I promise to come back in a couple days time with another video. In the meantime, stay safe and have a nice day. Bye-bye.